Welcome children. Now we are going to revise again from the same unit, light, reflection, refraction. From that, next you want to know about sign convention. That we already discussed before. So, here are some questions to you. First question is this: from where we measure distances? That means in the case of a mirror, from where we measure the distance. When we consider sign convention, where or in which direction we take a distance. And also another question, distance to which direction is positive and to which direction is negative. When you are remembering about sign convention, first of all you want to remember from where we want to take all the distance and to which direction we want to consider as positive and to which direction it will be negative. See that you already know, we discussed it in our class, in our regular class. So can you remember? In the case of a spherical mirror, is it concave or convex? This point is the pole and this point its principal focus, and this is the center of curvature. When we discuss about H, we said that is the point P as the pole. So here all the distance we measured from the point P. First question here given, from where we measure the distances. From where? From the point, that means this point P is the pole, and from this pole we measure all the distance. When we measure distance from pole, one thing you want to remember, we consider light rays incident from left to right. In which direction? Light rays coming to the mirror from left to right. And the distance in which direction we take as positive. See, that means in the direction of light rays, that means in the direction of light rays means this is the direction of light ray. So if the distance is taken in the direction of light rays, that means if some distance is here, that will be positive. Here, when we measure distance from pole, some point here, suppose from pole to focus or from pole to center of curvature, this is the opposite. So it will take us negative. This is the one rule to find in which direction we can take us positive and in which direction it will be negative. That means we take distance from the point pole to left, or that is to its left or right. If it is in the left, it will be negative, and if it will be in the right, it will be positive. This is one rule. That is right of the pole is positive and left of the pole is negative. Another ray is also there. That is in the direction of light ray. If we take, that means if the direction of light rays is opposite to the direction, then it is a negative. These are the two methods which we take positive and negative when we measure distance. And above these principles, the distance, there is some height here that will take us positive, and below it is a negative. This is the consideration in new Cartesian sign convention. New Cartesian sign convention, how we can consider positive and negative distance. Now, I hope you got idea about these two questions answer from where we measure distances. Can you remember now? Yes. Next question, distance to which direction is positive and distance to which direction is taken as a negative. Now, see, when an image is getting, or when an image is formed by a concave mirror, for example, suppose here is an object from the pole. This distance is taken as u. That means distance from pole to the object. It is considered as a object distance. Object distance, and it is taken as by the symbol, taken as by the symbol u. And suppose here we got an image of this. Then this distance from pole to this image is taken as v. And suppose somewhere here is its focus, and this distance is taken as focal length. A relation is there connecting this u, v and f. A relation connecting this object distance, image distance and focal length. And what is the name of that relation? That is a relation which connects this u, v and f. Name the relation, and that relation is and it is called a mirror formula. What is called a mirror formula? Which then is that formula is 1 by u plus 1 by v is equal to 1 by f. This relation, what is actually means by mirror formula? A relation connecting u, v and f. A relation connecting u, v and f, and that connected in this way, 1 by u plus 1 by v equal to 1 by f, and this relation is called mirror formula. When we substitute the numerical values of u, v and also f, we apply sign convention. When we apply, suppose the distance from pole to object, and that distance we taken, and also image distance and focal length, and these distances when we substitute in this relation, we consider or we take what? Sign convention in this relation to solve. Now, when we consider, one question to you, when we consider the sign convention in the mirror formula, when we put the numerical values in this relation, we consider new Cartesian or sign convention here. Now, when we discuss about the mirror formula, we know the relation. This is a mirror, this pole, and this is the, suppose this is the focal length, we can use a small letter, and here is an object, and this distance you use object distance, and this OB or H is the height of the object, and here suppose we got in an image I M and its height H dash, and this distance image distance V. Now this object distance and this image distance, object height, image height, this object distance, image distance. Now, is there any relation between this UV and height of object and height of image? A relation that connecting the height of image to height of the object, that is termed as a new quantity that you can remember, which is that magnification, and we used to represent with this letter M. Magnification M is equal to get a magnification, which ratio is we consider here? That you know, because we discussed in our regular class. So magnification, is it the height of object by height of image, or it is the image height by object height? Yes, magnification is the ratio of height of what image by height of object. That is, height of image is h dash, height of object is what? H. So this will get M is equal to h dash by h. Here we know height in the downside is negative, this will get upside positive, and the ratio M is equal to h dash by h. That is the magnification. It is the ratio of height of image to the height of object, or simply we can say how many times the image we got when we comparing with the object, that ratio. So M is equal to h dash by h. It also equal to M is equal to minus V by U. M is equal to minus V by U. So M equal to minus V by U is also connecting what? Magnification, and it is equal to h dash by h. So M equal to V minus of V by U, that is also equal to h dash by h. See, when we consider M is equal to h dash by h, in this case, see, height of image, this is the object and this is image. Here h dash is that height is negative and here is positive. Here the image, if it is real, then only we get what is inverted on. In the case of a concave mirror, if we get an inverted image, then that is real. Then only it become what is negative. So negative by positive, that is a magnification we get as a negative. Here magnification is negative means image is real. So from this we can ask one question: when does magnification negative, or when the magnification is negative, is the image is real or virtual? What is the answer for this question? That if the magnification is negative, then the image is real. If the magnification is negative, image is real. That is the conclusion we can get from this magnification. So these two things, you know, when does magnification is positive? If the magnification is positive, then the image is virtual. Now some questions to you. What happens when light rays enters from one transparent medium to another? Try to remember answer to this question. Once again, what happens when light rays enters from one transparent medium to another? I hope you got answer for this question. Now another question: is it travels along straight line or change its direction? Once again, is it travels along a straight line or change its direction? Again, I hope you got answer for this question also. And another question: why a pencil placed in water displaced? Suppose when we place a pencil in a beaker containing water, what happened? It appears displaced. Once again, these three questions: what happens when light rays enters from one transparent medium to another? You know what is transparent? A medium which through which light passes. Through which light passes. Is it travels along a straight line? That means the light rays before entering and after they are traveling along the same straight line. Another question: when a pencil placed in water displaced? These questions give one answer. That means when light rays, suppose this is a glass slab. It is a transparent medium. This glass slab is a transparent medium. When light enters in it, this is the incident ray. What happens this one? Is it travels along the same path as this way, or it displaces this way? Actually, what happened? These light rays displaced or bent at the surface of separation of the two media. These are the two media: above air, below glass. At this point, the light rays deviate. So this light ray now does not travel along the same straight line path. And this phenomena is called what? refraction. What is that term? And that term is a refraction. That means deviating or bending light rays from its axial path when it travels from one transparent medium to another transparent medium, and that is called what? A refraction. What it is? A refraction. Now we want to know how light is refracted when it travels from one medium to another, such as from air to a glass slab. See, this is a glass slab. Placed on a sheet of paper, and we draw outline and taken out this one with these sides A, B, C, D. Now arrange two pins in a straight line vertically. Suppose this is a pin and now this another pin. Now that means after placing this, that means first of all we draw outline of a rectangular glass prism. Rectangular glass slab. Then take it out and mark it as A, B, C, D. Again place the glass slab on this frame. Then arrange two pins. Suppose this pin E and F are two pins in vertical and they are along a straight line. Now keep again this slab, and by looking through this side, arrange suppose E, F, two more pins, which is G and H. When we look, we can see these four pins are on the same line. But when we look through this point, we can see this E, F, G, H. That four pin that is standing in a straight line. Now join this with the on line. Now suppose here we draw on perpendicular at this point. This point is suppose on perpendicular N dash. And also we join these 2 points. And here also we drawn on perpendicular. Let this one is O dash. And this M dash. Now join this. See this light now bend here. That means light is bending at the point O when it travels from air, this glass. That refractor ray bend towards the normal. Refractor ray bend towards the normal. And when it travels from glass to air again, that bend away from the normal. Now draw this line in this way. We can see this incident ray and this emergent ray, these two are parallel, This incident ray and the emergent ray parallel, but they deviated. Here we can see the refraction of light rays. Here, two questions to you. One, when light travels air to glass, refracted ray move towards the normal or away from the normal. What is the answer for this one? When the light ray passes from air to glass, this air is a rare medium and the glass is denser. Is it moved towards the normal? This is the normal. Is it bend towards the normal or away from the normal? It bend towards the normal. Now see, light is passing from glass to air. That means a denser medium to a rare medium. What happens to this all? That is actually bend away from the normal. That too, bend away from the normal. Now, you got answer to these all questions. What happens when light rays enters from one transparent medium to another? Its answer is light ray deviates. Is it travels along a straight line or change its direction? Answer, changes its direction. When a pencil placed in water displaced why? That means when a pencil placed in water, light rays coming from the sides of the pencil inside the water appears from different directions as compared the light from the surface above the water. So, light from the pencil which is coming from water, that appears coming from different directions. So that pencil is displaced. So the pencil is displaced. That is the reason why the pencil is displaced. Now, another question. Does the extent of displacement in water is same as in the kerosene or turpentine? Once again, does the extent of displacement, we know that light when it travels from one transparent medium to another, it gets displaced. Now the question, does the extent of displacement in water is the same as in kerosene or turpentine? That means the extent of displacement is not the same as that in water. It depends on the medium through which light it passes. That means extent of displacement or deviation depends on the medium through which light passes. That means extent of deviation depends on different medium at the different rate. That means different pairs of medium that depends. And also light does not travel through all medium in the same direction. That means light traveling through different mediums depends on different amount. Now, what is refraction of light? What is actually a refraction of light? What is actually a refraction of light? Refraction of light is the phenomenon that happens when light travels obliquely from one transparent medium to another. It is displaced or bent at the surface of separation of the two media. That means light is displaced or light bent at the point of separation of the two media. And actually this bending or displacement happens because of what? Because of the difference in speed of light in different media. Difference in the speed of light in the different media, because of that light refracted. And if the light travels normally to a medium, then we cannot observe any deviation. If the light travels normally from one medium to another, then we cannot observe any deviation in that case. There are two laws related to refraction of light. Can you say which are they? Which are the two? On incident ray. Incident ray, refractor ray, and normal. Incident ray, refractor ray, and normal at the point of incidence where the two surface separates that lie on the same plane, which are incident ray, refractor ray, and normal. They lie in the same plane. Now, second one, sine of the angle of incidence to the sine of the angle of incidence to the sine of the angle of refraction. Sine of the angle of incidence to the sine of the angle of refraction. If we take the ratio of these two, that means the ratio sine of the angle of incidence to the sine of the angle of refraction, that is sine I by sine R, is equal to a constant. That is equal to a constant. And this constant is called refractive index of the second medium with respect to the first medium. That means sine of the angle of incidence and also sine of the angle of refraction. If the ratio of these two, that means the ratio of sine of the angle of incidence to the sine of the angle of refraction is equal to a constant. And it is called a refractive index of second medium with respect to the first medium. Refractive index of the second medium with respect to the first medium. These are the two laws of refraction, that is incident ray, refracted ray, and normal at the point of incidence that are lying in the same plane. Second one, sin I, that is sine of the angle of incidence. Then sin R, that is sine of the angle of refraction. That ratio is equal to a constant. And this constant is called refractive index of the second medium with respect to the first medium. Usually this refractive index we used to represent with the letter N. Let us consider two media. Medium 1, through which the speed of light is, let it be v1, and second medium 2, through which the light travels at a speed of v2. Now, refractive index of second medium with respect to first, that is n to 1. That is refractive index of second with respect to first is equal to speed of light in first by speed of light in second, or n to 1 is equal to speed of light in first, that is v1 by v2, second with respect to first. And if speed of light first one is v1 and second one is v2, suppose we are taking refractive index of first medium with respect to second, that means n1 2. First medium with respect to second one, then what will get v2 by, it will be v2 by v1. This refractive index of first with respect to second, that is n12 is equal to v2 by v1. When we consider different media, the speed of light in vacuum is the maximum when we consider different media. The media through which light travels with the maximum speed is vacuum, that is 3 into 10 raised to 8 meter per second, and that speed if we take as c, and vacuum or air may be equal, that means 2.9998 into 10 raised to 8 meter per second. When we consider air or vacuum with respect to another medium, then that refractive index is called absolute refractive index. When we consider refractive index with respect to air or vacuum, we used to say it is as absolute refractive index, that is Nm is equal to, that is speed of light in vacuum c, and let v be the speed of light in any other medium, then Nm, that is absolute refractive index Nm is equal to c by v. Here c is the speed of light in vacuum, that is 3 into 10 raised to 8 meter per second, and that in any other medium v, that it may be air or water, etc. And in the case of refractive index of air or vacuum with water, it will be, that means n for water, that means refractive index of water is equal to 1.33, and for kerosene it is n, that means refractive index of kerosene it is 1.41 in this way. See, here we consider optically denser medium is which, that means when we consider refractive index here, this is optical denser medium, kerosene, but water is lesser. But we consider, when we consider density of water, it is more, but when we consider optical density, it is more in the case of what is kerosene. So here we want to remember about refractive index. How we find out the refractive index, or what is the relation connected refractive index with the speed? Refractive index is second with the first n to 1. That means this first will come up and this one is second. That means n to 1 is equal to v1 by v2. If n12 is equal to this 2 up and this one is down. That means v2 by v1. When we consider refractive index with air or vacuum, then it is called absolute refractive index, and we used to represent with nm or simply n or simply m, simply n, not m, that is equal to c by v. So with this all, we can conclude this class. Thank you.